Hello and welcome guys to another lesson of Mossy Maths, where today we're going to be looking at integration with definite integrals. Now a definite integral is where you have an upper limit and a lower limit to the integration. So all we do here is we integrate the function as usual, and then we substitute in our upper limit and then subtract our lower limit from our upper limit. Okay, so we're substituting in both these and subtracting our lower limit answer from our upper limit answer. So if that doesn't make complete sense right now, I hope it will once we go through it. So here's a very quick example that I'm going to go through, and then we're going to look at how to apply this straight away into an exam style situation. So hopefully this isn't too hard. So all we're doing is integrating this function as usual, adding 1 to the power, dividing by the power. So we get x to the 3 divided by 3 plus 2x. Remember, the 2 just becomes 2x when it's integrated. So here's our integrated function, and now we need to evaluate it. So we have to substitute in firstly our upper limit, which is 3. So substituting x is 3 into here, we get 3 cubed, which is 27, divided by 3 is 9, plus 2 multiplied by 3, which is 6. This gives us 15. So when we substitute in our upper limit of the integral, we get 15 as an answer. So now we need to substitute in our lower limit. So we should say here we're doing f of 3, which just means we're substituting in our upper limit. So now if we do f of 1, 1 cubed is 1, divided by 3 is a third, plus 2. So a third plus 2 gives us, well, that's 6 over 3 plus 1 over 3, which is 7 divided by 3. Okay? So to find the answer, all we have to do is subtract this from what we calculated to be our upper limit value, which is 15. So all we're doing is 15 minus what we got when we subbed in our lower limit. So a good way to do this would be to make both divided by 3. So 15 can become 45 divided by 3. Minus 7 divided by 3. And this gives us, that's going to be 38 over 3. Now exam boards tend to like this written as having a whole number followed by a fraction rather than having a top-heavy fraction. So in this case it will be better to write this as, so that's going to be 10, 11, 12 and 2/3. Okay, so that's going to be 12 and 2/3. So, looking at our next example, it says find the area between the graph of y equals x squared, the x-axis and the lines x is minus 1, x is 2. So here's the graph drawn out for you. In the exam it's likely you'll be given the graph drawn out for you. If not, then it'll be made very clear what you've got to do. So here, we're trying to find these areas under the curve. Now this is the main use of integration. Although we've not actually tried an example with it yet, all integration is used for here is finding this area. So all we're doing is substituting in minus 1 and 2 as our lower limit and upper limit. So that's why we went through this example here, to show you what we're doing. But now we need to form the question ourselves. So, we can see it's asking for this area between minus 1 and 2. So, all we do is make minus 1 our lower limit and 2 our upper limit. And then we evaluate this function, which is what the curve is, because we're finding the area under that curve. So, effectively, we now have a similar question to what we have here. In fact, probably even easier than this. So we have to now integrate this, and we get x cubed divided by 3. And remember, we now have to sub in 2 and minus 1. So firstly, substituting in 2, our upper limit, into this integrated function, we get 2 cubed, which is 8, divided by 3. And now we need to substitute in our lower limit. Minus 1 cubed is minus 1. Divided by 3 is minus a third. So, we need to be very careful here, because we're subtracting our lower limit from our upper limit answer. So we're subtracting minus a third from 8 over 3. Okay, so 8 over 3 minus a third. So this is going to become a positive, okay? This is going to become 9 divided by 3, which is 3. So this is the area under the curve. The answer is 3. We don't have units, we just write 3 here. So what seemed like a difficult question has actually turned out to be quite simple. All we do is find what our lower limit and upper limit will be by looking at the graph in the question. And then we integrate as usual and evaluate this by substituting in our upper limit and lower limit. And that way we can find the area under the curve. In an exam you're looking at getting 4 marks for this. And that's quite a lot of marks considering that it's not actually that difficult. The hardest bit is forming the question yourself, seeing what the question's going to be. This is quite an easy example. In future videos we'll be looking at even more difficult examples, and that's it for this lesson. So if you have any questions, please put a comment below. If you like the video, then please subscribe to my channel, where I'll be making more videos on AS Maths. So thank you very much, and I'll see you in lesson 5.